Welcome to StackTrekker. In this tutorial, we'll explore SQL Joins, one of the most important concepts in relational databases. Here's what we'll cover: how joins allow you to combine data from two or more tables using a related column, the four main types of joins and when to use each, clear real-world examples using simple tables to show exactly how joins work. Let's get started. In SQL, a join is used to combine rows from two or more tables based on a related column between them, typically a key. For example, imagine you have a customers table that stores customer information and an orders table that stores purchase data. Each order in the orders table contains a customer ID that references the ID in the customers table. To find out which customer placed which order, we use a join to merge the relevant data from both tables into a single result set. This allows us to retrieve detailed information such as the customer's name along with their corresponding order details. There are several types of joins in SQL, including inner join, returns only the rows where there's a match in both tables. Left join returns all rows from the left table and the matching rows from the right table. If there's no match, you'll see nulls for the right table's columns. Right join, similar to left join, but it returns all rows from the right table instead. Full outer join includes all rows from both tables. Where there's no match, nulls are shown for the missing side. Now let's learn how to understand these joins in action and how to use them in real SQL queries. In this tutorial, we'll be using DBeaver, a powerful and user-friendly SQL tool that supports many different databases. To get it, just go to Google and type DBeaver Community. We're going to use the free Community Edition. That's more than enough for everything we'll do in this tutorial. On the download page, you'll see options for Windows, Mac OS, and Linux. I'll be installing the version for Mac with Apple Silicon, but if you're on Windows, just pick the Windows version instead. Once the file is downloaded, go through the usual installation steps for your system. After starting DBeaver, you'll see the main window of the program. On the left side, you'll find all possible database connections. This means you can create and work with multiple databases in parallel. Super useful for managing different projects. In this tutorial, we won't install any special database software, but we still need a database to work with. So how do we do that? There's a simple solution: the H2 embedded database. It runs completely in memory or from a few small files on your system. Later, if you want to move your database to another computer, you can just copy those files, no extra installation needed. Let's create a connection to our database. Right-click in the Database Navigator on the left and select Create Connection. In the dialog that appears, type H2 in the search box. You'll see a few options. We'll choose H2 Embedded because we just need a simple lightweight setup for this tutorial. Next, we need to choose the folder where our database files will be stored. The database is up and running. It's currently empty, so we need to create some tables and insert some data. I've prepared a script with test data for you, and you can download it using the link shown on the screen. You'll also find the same link in the video description below. All right, once you've downloaded the script file, let's insert the data into our database. To do that, go to the File menu in DBeaver and open the file you just downloaded. This script will create two tables with data that we'll use throughout the tutorial. Once the script is open, usually in a new tab or window, we need to make sure it's connected to the correct database. At the top, select the database we created earlier as the target connection. Now, click the Execute button to run the entire script. Let's double check. With DBeaver, it's super easy. Just expand your database on the left, select Tables, and refresh the tree. You'll see the Departments and Employees tables. Right-click the Departments table and select View Data. Here, you can see the actual rows stored in the table. You can do the same for the Employees table. Just right-click it and select View Data to view the employee records. In our first example, we'll explore how to use an inner join to combine data from two related tables, employees and departments. Let's say we have a table called Employees with details about each employee, including their department ID, a table called departments that contains department names and their IDs. We need to connect these two tables via the department ID. To do this, we use an inner join. An inner join returns only the rows where there is a match in both tables. In our case, that means an employee's DEP ID must match a DEP ID in the departments table. If there's no match, for example, if the employee is assigned to a department that doesn't exist or not assigned at all, that employee won't appear in the result. So the inner join helps us combine and filter data only where a relationship exists between the two tables. Now let's write the query. Here we're selecting the emp ID and name from the employees table. We're also selecting the name from the departments table. The inner join keyword tells SQL to match rows from both tables only where the DEP ID values match. This means we'll only get employees who are assigned to a valid department. Let's check the result. As you can see, we have only 3 employees who have a matching entry in the departments table. Employee David has no department assignment, and Eve is assigned to a department that doesn't exist in the departments table. Because of this, neither David nor Eve appears in the result of the inner join. And that's the key point. An inner join only returns rows where there is a matching value in both tables being joined. The left table, employees, and the right table, departments. If an employee has no department or their department ID doesn't exist in the departments table, that row will be excluded from the result. But what if we want to keep all employees even if their department is missing? Here's where the left join comes in. A left join returns all rows from the left table, in this case, employees, and the matching rows from the right table, departments. If there's no match, the result will still include the employee, but the department name will be null. Let's update the query to use a left join. What's the difference? Inner join returns only the employees with a valid department. Left join returns all employees, whether their department is valid or not. This is useful when we want to check for issues in the data, for example, employees not assigned to any known department, or simply want a complete list regardless of missing information. Let's check the result. As you can see, we now see all employees and their corresponding department names. If the department can't be identified, null is returned. The left join always shows all employees, but is there a way to show all departments even if they don't have any employees assigned? Yes, and that's where the right join comes in. A right join is the opposite of a left join. It returns all rows from the right table, departments, and the matching rows from the left table, employees. If a department has no employees, you'll still see it in the result with null values for the employee-related fields. Let's write the updated query. Now check the result. For every department in the departments table, SQL will try to find a match in the employees table. If a department has 1 or more employees, you'll see the employees listed with it. If a department has no employees, you'll still see that department, but emp ID and employee name will be null. Here's a quick summary of what we've covered so far. Inner join gives us only the rows where there's a match in both tables. Left join keeps all rows from the left table. Right join keeps all rows from the right table. But what if we want to see everything, all employees and all departments, even when there's no match between them? That's where the full outer join comes in. A full outer join returns all rows from both tables. Let's write the query. The syntax is similar to what we've done before, but if we try to execute it, we'll get an error. Unfortunately, not all databases natively support this type of join, and our H2 database is one of them. So, what can we do? Remember, a full outer join is essentially the combination of a left join and a right join. To achieve the same result, we can use another SQL command, union, to merge the results of both joins. Let's do it step by step and simulate a full outer join using left join plus right join plus union. So here we write the left join and the right join and use the union command to combine their results. The union operator adds the result of the second query, the right join, to the result of the first query, the left join, while automatically removing any duplicate rows. After executing the query, we can see the combined result, which effectively simulates a full outer join. If there's a match between an employee and a department, they're shown together. If an employee has no department, the department fields will be null. If a department has no employees, the employee fields will be null as well. This technique is a useful workaround when your database system doesn't support full outer join natively, like in the case of the H2 database we're using. That's all for today. This topic was both interesting and essential for working with relational databases. I hope you now feel more confident using joins in SQL. So I hope this was interesting. Thank you for watching my tutorials. If you enjoyed this, please like the video and subscribe. See you later. Bye.